This is the problem number 2 from exam number 1, spring 19. This problem belongs to section 3.1. Let f be this function. Find the derivative of function f at point 3 from the definition. The definition of derivative is these two formulas. The definition says that a derivative is a limit. Let me use this formula to compute the derivative in this problem. By this formula, derivative of function f at point 3 is this limit. To find f of 3 plus h, replace all the x by 3 plus h here. Then f of 3 plus h is this quotient. To find f of 3, replace all the x by the number 3. Then f of 3 is this quotient. Simplify the numerator, then I have this equation. To find this limit, we can try direct substitution. Plug in 0 in h, but then we will have 0 over 0. We cannot tell the limit. So to find this limit, we need to simplify this function. I use common denominator to simplify the numerator. I write the second term 8 as 8 times 1 plus h over 1 plus h. Then on the top, the two terms have the same denominator. Therefore, I can combine the two terms to get this equation. Now, distribute the negative sign, negative 8 to 1 and to h. Then I have this equation. Cancel the number a, and h minus a times h is negative 7 times h. Then I have this equation. Then write this quotient as this quotient times 1 over h. Cancel h, then I have this equation. Now, direct substitution. Plug in 0 in h, then this limit is this number. This number is negative 7. So derivative of this function f at the point 3 is negative 7. Problem number 3. This problem is also from exam number 1, spring 19, and also belongs to section 3.1. Multiple choice. Circle the correct response. Part A. The average rate of change of a function f on the interval from 0 to 2 is b. Recall that the average velocity of a moving object over a time interval from a to b is the position of the object at b minus the position of the object at a over b minus a. This quotient is also the average rate of change of the position of the moving object. Similarly, the average rate of change of a function on an interval is function value at the right endpoint 2 minus function value at the left endpoint 0 over right endpoint minus left endpoint 2 minus 0 2. Therefore, B is the correct answer. Part B. The instantaneous rate of change of function f at point 2 is B. The instantaneous rate of change of function f at point 2 should be derivative of f at 2. By definition, derivative of f at 2 is this limit. The limits in A, C, and D are close to this limit, but still different. The limit in A here should be 2. The limit in C here, h should approach 2 rather than h approaches 0. The limit in D here should be 2, and the bottom should be h. So the answer is B. Part C. If an object has position s of t at time t, then its average velocity during the time interval from 0 to t is B, by the average velocity formula. Part D. If an object has position s of t at time t, then its instantaneous velocity at time t is 0 is A, because derivative on position function is instantaneous velocity. Problem 5. This problem is also from exam 1, spring 19, and also belongs to section 3.1. The number of people in a theater at time t is given by a function f of t. Values recorded at 2-minute intervals are tabulated as shown in this table. Part A. During the entire 8-minute interval, what was the average rate of increase of pupil in the theater? This question actually is asking what was the average rate of change of function f over the time interval from 0 to 8. By formula, the answer is function value at 8 minus function value at 0 over 8 minus 0. Function value at 8 from the table is 117. Function value at 0 is 5. So I have this equation. By calculator, this number is 14. So the answer is 14 pupil per minute. Part B. Give a reasonable estimate for the instantaneous rate at which people were entering the theater at time t is 5. The instantaneous rate at time is 5 is derivative of function f at 5. Derivative of function f at 5 is the slope of the tangent line to the graph of function f at 5. Suppose this green curve is the graph of function f. Suppose this point is The point on the graph corresponding to time is 5. At this point, draw a tangent line. Then the slope of this tangent line is derivative of f at 5. To estimate the slope of the tangent line, I pick on the graph 2 nearby points. One is 4, f of 4. The other one is 6, f of 6. Then join these 2 points with a line. This line is a secant line. I want to use the slope of this secant line to estimate the slope of this tangent line. The slope of this secant line by the slope formula is y2 minus y1 over x2 minus x1. From the given table here, function value at 6 is 61. Function value at 4 is 25. Then I have this equation. By calculator, this number is 18. So I estimate the instantaneous rate at time is 5 is 18 pupil per minute. Now I present exam 2, Sprint 19. Problem 1. Use the graph of function f shown on the right to answer the questions A, B, C, and D. Question A. Give the values of x in the open interval between 0 and 5, at which the function f is not continuous. At x is 0.5, the graph is not continuous. When we draw the graph, at x is 0.5, we have to lift up our pen from the paper. So the answer to A is 0.5. Question B. Give the values of x in the open interval between 0 and 5, at which the function f is not differentiable. The answer to question B is 0.5 and 2. At x is 0.5, the graph is not continuous. When the graph is not continuous, there is no tangent line. Because derivative is slope of tangent line. No tangent line, therefore no derivative. In other words, not differentiable. At x is 2, the graph has a corner. At the corner, no tangent line, so no derivative. So at 0.5 and at 2, the function is not differentiable. Question C. What is the value of derivative at 3? Derivative at 3 is the slope of the tangent line at this point. The tangent line at this point is this line. About this line, we know at least 2 points on it. One is this point. X coordinate is 2. Y coordinate is 5. The other point is this point. X coordinate is 5. Y coordinate is 2. Because we know 2 points on this line, we can tell the slope of this line by the slope formula. Slope formula, y2 minus y1 over x2 minus x1. So the slope of the line is -1. The answer to question C is -1. Question D. Which of the following could be a graph of the derivative of f? Consider this portion of the graph of function f. About this portion, if we draw tangent lines, then we will see that all the tangent lines have negative slopes. On the other hand, if I move x further and further away from the origin, then this portion of the graph becomes steeper and steeper. In other words, slope becomes larger and larger, but negative. Based on the observation about this portion of the graph, I can make decision. I choose this diagram to be the graph of the derivative of f, because between 0 and 0.5, the graph is below x-axis. That means that negative. And as x is increasing, this curve is decreasing. Problem 2. The table below gives selected values of differentiable functions: f, derivative of f, g, derivative of g. This problem has 5 questions. Let me present only question D. Question D. If w is g of f of x, find the derivative of w at 2. This function is a composite function. To compute its derivative, we have to use the chain rule. I let u denote f of x. Then the function g of f of x becomes g of u. In this derivative, x and u are different. We cannot compute this derivative without using the chain rule. By the chain rule, I write this derivative as the product of these two derivatives. If I cancel du, then this product will go back to this derivative. Derivative of g of u with respect to u in the prime notation is g prime of u. Now, delete u by plugging f of x in the u here. Then I have this equation. Derivative of f with respect to x in the prime notation is f prime of x. Now, plug in 2 in the x here, then derivative of w at 2 is this. From the table, f of 2 is 3. This is x is 2. This column is function f. Function f at 2 is 3. Also from the table, derivative of g at 3 is 3. Derivative of f at 2 is 4. Therefore, derivative of w at 2 is 12. Problem 3. In each case, find the required derivative. Simplification is not required. This problem has 6 questions. Let me pick 2 questions to answer. Question B. F is cosine to the fifth of x. Cosine to the fifth of x is equal to cosine of x to the fifth. To compute this derivative, I use the chain rule. I simplify the function by introducing u. I let u below cosine of x. Then the function becomes u to the fifth. To compute this derivative, I apply the chain rule. I write this derivative as the product of these two derivatives. If I cancel du, then the product is this derivative. Derivative of u to the fifth with respect to u by the formula for power function, it is 5u to the fourth. Now delete u. Plug in cosine of x in the u here. Then I have this equation. Derivative of cosine of x with respect to x is negative sign. This is the answer to question B. Question E. The function g is a quotient. So to compute the derivative of function g, we need the quotient formula. By the quotient formula, derivative is derivative of the top times the bottom minus the top times derivative of the bottom, then all divided by the bottom square. Derivative of 2x minus 1 is 2. To compare this derivative, I need the chain rule. I simplify the function by introducing a u. I let u below x plus 4. Then x plus 4 to the third. This function becomes u to the third. Now apply the chain rule to this derivative. Write this derivative as the product of these two derivatives by inserting du to the bottom and du to the top. Derivative of u to the third with respect to u is 3u squared. Now plug in x plus 4 in the u here, then I have this equation. Derivative of x plus 4 with respect to x is 1. Therefore, this is the derivative of x plus 4 to the third. Plug in the result here, then I have this equation. I can stop here because this problem, number 3, doesn't require us to simplify our result. Problem 4. Function f is natural log of 2x minus 4. Find and simplify the following derivatives. Part A. Compute the derivative of function f. The function is a composite function, so I need the chain rule to compute the derivative. I simplify the function by introducing u. I let u below 2x minus 4. Then the function becomes natural log of u. Natural log of u, derivative with respect to x. To compute this derivative, I need the chain rule. I insert du to the bottom and to the top and make the derivative become the product of these two derivatives. Derivative of lateral log of u with respect to u by the formula, it is 1 over u. Now, plug in 2x minus 4 in the u here. Then I have this equation. The derivative of 2x minus 4 with respect to x is 2. Then simplify this quotient by taking out 2 from the bottom and canceling 2. Then this is the answer to part A. Part B. Find the second derivative of function f. In part A, we have obtained the first derivative. The result is 1 over x minus 2. Now, take derivative again. Because 1 over x minus 2 is a quotient, we apply the quotient rule to compute this derivative. By the quotient rule, this derivative is equal to derivative on the top times the bottom minus the top times the derivative on the bottom. Then divided by the bottom square. Derivative of 1 is 0. X minus 2 derivative is 1. Then 0 times x minus 2 is 0. Minus 1 is negative 1. Move the negative sign to the front. Then this is the result of the second derivative of function f. Problem 5. This problem is about implicit differentiation. The graph of the relation is shown in this diagram. This curve is the graph of the relation. Part A. Does the point 1, 0 satisfy the relation? Plug in the point into the relation. Then it is easy to see that the left side is equal to the right side. Therefore, the point satisfies the relation. Therefore, this point is on the graph of the relation. Part B. Find the slope of the tangent line to the graph at the point 1, 0. From part A, this point 1, 0 is a point on the graph of this equation. At this point, there is a tangent line, and we need to find the slope of the tangent line. To find the slope of the tangent line, we need to compute derivative y prime. After we get y prime, plug in the point 1, 0 in y prime to get the slope of the tangent line. To find the derivative y prime, take derivative on the both sides of the given equation. Then we have this equation. Apply the summation rule to the derivative on the left side. Then we have this equation. This equation contains 1, 2, and 3 derivatives. To compute the first derivative on e to y with respect to x, we use the chain rule. By the chain rule, we can write this derivative as the product of these two derivatives. To compute the second derivative, we apply the product rule because the function is a product. Y depends on X. Y plus 1 therefore depends on X. So Y plus 1 is a function of X. X squared depends on X. It is a function of X. So Y plus 1 times X squared is a product of two functions. By the product rule, this derivative is equal to derivative of the first function, y plus 1 derivative, times the second function, x squared, plus the first function times derivative of the second function. Y plus 1 derivative by summation rule is y derivative plus 1 derivative. Derivative of e to y with respect to y by formula is e to y. 1 derivative is 0. So y prime plus 1 prime times x squared is y prime times x squared. X squared derivative is 2x. Number 3 derivative is 0. So we have this equation. Solve this equation for y prime. Then plug in the point 1, 0 into y prime to get the slope of this tangent line. But we don't have to solve the equation for y prime, then plug in the point to get the slope of the tangent line. We can directly plug in the point 1, 0 into this equation to get the slope of the tangent line. For the purpose, let me denote the slope of the tangent line by m. That is, m is equal to y prime evaluate at the point 1, 0. Now, plug in the point 1, 0 into this equation. Plug in the point in e to y, then we have e to 0 because y is 0, x is 1. Plug in the point in y prime, then we get m, the slope of this tangent line. Plug in the point in this y prime, we get m. Plug in the point in x squared, we get 1 squared. Plug in the point in y, y is 0, so we get 0. And plug in the point in x, we get x is 1. So we have this equation. Solve this equation for m. E to 0 is 1. And m times 1 is m. And this number is 2. Now solve this equation for m. Then we get m is negative 4 over 3. So the slope of this tangent line is negative 4 over 3. Part C. Determine the equation of the tangent line to the graph at point 1, 0. That is, we need to write down the equation of this tangent line. About this tangent line, now we have its slope, negative 4 over 3. And also we have one point on the tangent line. The point is 1, 0. By the point slope formula, we can write down the equation of this tangent line. This is the point slope formula of a line. By this formula, y minus y1 now is 0. It's equal to slope. Slope is negative 4/3. Parenthesis x minus x1. x1 is 1, the x coordinate of this point. Now, simplify this equation, then this is the answer to part C. Part D. In the graph given above, sketch and label the tangent line found in part C. This red line is the tangent line found in part C. It is the tangent line to the graph of this equation at the point 1, 0. Problem 6. A ball is thrown upwards and has height above the ground in feet given by this position function. T is time in seconds. Part A. Determine the velocity of the ball at time t. What are the correct units of velocity? Velocity is derivative of position function. Take derivative on the position function, then the velocity is negative 32 times t plus 160. The units of the velocity is feet per second. Part B. Determine the acceleration of the ball at time t. What are the correct units of the acceleration? Acceleration is the derivative of the velocity. Take derivative on the velocity, then we have negative 32. So acceleration is negative 32. The units of the acceleration is feet per second square. Part C. At what time does the velocity of the ball equal 0? To answer the question, set velocity to 0 and solve this equation. Then we have time is 5. Part D. At what time is the ball at ground level? To answer the question, set the position function to 0 and solve this equation. Then we get time is 0 and 10. At these two times, the ball is at the ground level. Problem 7. The line y is 3x minus 5 is tangent to the graph of a function f, at the point 2, 1. Determine the following values. Function value at 2 and the derivative of f at 2. To help myself answer the questions, I arbitrarily draw a curve. And suppose this curve is the graph of function f. Suppose the point 2, 1 is here. It is on the graph. At this point, there is a tangent line. The equation of the tangent line is this equation. It is given. From this equation, we see that the slope of the tangent line is 3. Now, because 2, 1, this point is on the graph of function f, the y coordinate should be the function value at the x coordinate. Therefore, function value at 2 is 1. Derivative of f at 2 is the slope of the tangent line. The slope of the tangent line is 3. Therefore, this derivative is 3. Problem 8. Determine the indicated derivatives in simplified form. Part A. Derivative of e to e is 0 because e to e is a constant, doesn't depend on x. Part B. Derivative of e to x is e to x by formula. Part C. Derivative of x to e is e times x to e minus 1. X to e is a power function, so we can apply the formula for power functions to compute this derivative. Part D. Derivative of e to e times x. To compute this derivative, we need to simplify the function. I let u denote the power e times x. Then the function becomes e to u. To compute derivative of e to u with respect to x, we need the chain rule. Write this derivative as the product of these two derivatives. Derivative of e to u with respect to u is e to u. Now, plug in e times x in the u here. Then I have this equation. Derivative of e times x, e is a constant. Derivative of e times x is e. Now, e to e x times e is e to ex plus 1. This is the simplified form of the solution.